Excellent. Good. See, learning is fun. So as I said, what I'd like to do for the second half here is I want to go through at least one of each type of this sort of proof theoretic concepts that we talked about. So if you looked at all at the homework that's due next week, so it's on pages 130 and 131 in particular. I've asked you to do, I think, the odds. So I thought we could go through a couple of the evens from exercises A, B, and C. Now, in these cases, what it is, A is let's prove some theorems, B is just let's build some basic proofs, and C is show some joint provability. We'll also do a couple exercises about joint contrariness as well. I want to just make sure that we know what we're tasked with doing in these cases. It's also just helpful, just practice. So let's start off with a fairly easy one. And instead of doing the odds, because that's what we'll talk about in the tutorial, let's do the evens. Okay, so then we'll get full practice. So let's start with A2 on page 130. So A2, we're tasked with proving that this sentence is a theorem. So we're going to prove that this sentence is a theorem. So first thing, if we're proving that this is a theorem, how many assumptions do we have to start? None, right? None. Because what we're doing with a theorem is we're proving that it follows from no assumptions whatsoever. It's the equivalent, it's the proof theoretic equivalent of being a tautology. Basically, you can bootstrap this from nothing. So we're going to start by drawing our assumption line, dropping the proof line down from it, so basically just like a right angle, and our first numbered line is going to be below the assumption line. Because, of course, right, we don't have any to start with, so our first proof line is going to be underneath. Okay, so let's pause before we dive into it, and let's plan. Let's think about how we're going to do this proof. So we know that this is going to be the last line. So looking at it, what rule do we think we might use last?
The disjunction introduction?
That's really plausible, right? Again, a simple place to start is if the sentence, the conclusion, has an operator, first idea, let's think about using the introduction rule for that operator. So again, we're just planning here. We're thinking about what to do. So if our last move is going to be disjunction introduction, what do we need to have already in order to be able to use that rule to give us that sentence?
One of the atomic sentences.
Yeah, we need at least one of the two disjuncts, right? At least one of the two disjuncts. So in this case, we'd either need to have already gotten to N or to not N. Now before we go on, does everybody see the reasoning there, right? Again, all we're doing is we're just thinking about that last step and thinking about if we were going to use that rule, what would we already have had to have done? Good so far. And this is also helpful. Hopefully you guys kept them, right? The sheets with the rules on them, useful to look at here, right? Again, useful to kind of go back. If you didn't keep it, it's okay. It's at the back of the book. It should be. And I'll also make sure it's on the Canvas page. Make a big link so you see. Okay. So, okay. Again, coming back to our plan. If we could get to N or we could get to not N, it would be very easy. Now, interesting. When we hear N and not N, this should set off alarm bells. Right? What alarm bells does it set off? Yeah. That's an idea. That's an idea. But note that in order to get the contradiction, we'd already need to have both of them. And if we could get either one of them, we'd be already done. So I like it. But note that already would require us to get the things that we want to get to already. So cool. What other ones do we notice? Yeah?
You need elimination. combination rule?
It's an idea. I think this kind of goes hand in hand with your man here, right? Because one of them's an atom, so we're not going to get to n by using any introduction rule, because it's an atomic sentence. Yeah. Okay. So here's one, and again, a pro tip. If you ever see a circumstance like this should immediately make you think of the rule TND, tertium non datur. That's the fancy way to say no third way. So what does TND do? TND says, hey, if you can give me a subproof that starts with a sentence and gets to a result, and a subproof that starts with the negation of that first sentence and gets to the exact same result, then you know the result is the case. Basically, if P is true, we can get there. And if not P is true, we can get there. So then we know it's true. Good. What is the sentence we want as the result here? It's going to be this. It's going to be this.
Like N or
The disjunction. Watch. Right? So again, TND says, if you can give me a subproof that starts with a sentence and gets to somewhere, and starts with a negation and gets to the exact same place, then you know that that result is true. So let's start a subproof with n. And what can we immediately do at line 2?
Can we already say and or not and?
Yes. What's the rule?
Disjunction introduction.
Exactly. So look at what we did. Remember our plan. Our plan was we could easily get the conclusion if we could just get to here or here. Cool. So let's start a subproof with one of these and then just go boop. Because disjunction introductions cheap. Disjunctions are cheap. If you have a sentence, you can bolt on anything you want. Yeah.
so if you read out what we just did in line 1 and 2, what would it be?
Good. So it would say, if n is true, then n disjunction not n is true. That's interesting. But now, what do we want to do at line 3? Let's get. Look at the list. Look at the rule for TND.
Do we want to prove the negation of not and? Shall we assume not and?
So what we're going to do is we're going to close this subproof because it's done its job. It's done its job. And now we want to start our second subproof. This bit. Start with not in and get us to the same place. So if we want to get to the same place, what are we going to do at line 4?
I have a question.
Please.
For the disjunction, you only have to show one of them to be true, right? Then this is unnecessary. You already showed that.
But importantly, look at where the disjunction is. It's not on our main proof line. We've only got the disjunction inside the subproof. It required that we assumed n was true to get there. Again, just like I said to your man, what the subproof tells us is if n's true, then n or not n is true.
Yeah.
But that if part's real important, right? We want to get to dropping the if part. We want to drop the antecedent.
Oh, then so this conclusion, so n has to be.
Yeah. Right. So we're almost there, but we got to get to the same way. We got to show it doesn't really matter if n's true or n's false. You're going to get to the same result.
Disjunction introduction?
Disjunction introduction for line 4. Okay. Nice. So now then, what can we do at line 5? What's our move at line 5?
Yeah, then so no subproof and then just the sentence again.
Exactly. We have shown that it doesn't matter if you go through n or you go through not n, you end up at n or not n. Both ways lead to that. Now, that's great. What's the rule?
Yeah.
TND.
TND? Nice.
Or the entire circles, right? So 1 to 3 and 2 to 3 to 4.
1 to 2, 3 to 4, right? So for TND, what you cite is you cite the two subproofs. It's showing you, hey, one of the subproofs, if the sentence is true, you get to this result. The other subproof says if it's false, you get to the same result. So 1 to 2, and then 3 through 4. And again, what the citations are showing you is how you could read the proof back.
Why did we use this format and not the format for the disjunction?
Good. So notably, disjunction elimination has one extra step. What's the one thing that you also need for a disjunction elimination? You've got to have a disjunction to eliminate. Right? You have to have a disjunction to use. But with T and D, you don't need no disjunction. Because what you're secretly doing is you're using the fact that this sentence is a theorem. Every sentence of this form is a theorem. We just proved it. So that means it's always there to use as a disjunction. That's what T and D effectively does. It's good. It's a good question. Yeah.
Why would we have a disjunction to eliminate?
Good. So importantly, what we mean by that is, if you have as a premise something like this, if that's on your proof line, you can use it. You can eliminate that disjunction. But remember here, we started from nothing. So we didn't have a disjunction to use. Sorry, that was good. I didn't clock it at first. I was like, what did he say? So we didn't have anything to use. So there wasn't anything to eliminate. We couldn't have any toys to play with. We had to bootstrap the whole thing. So this is a nice question to go through because it shows something. Again, remember I said, when we prove that a sentence is a theorem, 99.9% of the time, our first move, kick open a subproof. That means that it's very likely you're going to be using one of the rules that requires subproofs. Right? You're going to have to. Yeah.
So why did you start with nothing like the other sentence? Because it's two different sentences.
It's two different sentences. Two different sentences. Note that there's no way we're going to get this is from nothing. Because this is not a theorem.
The only way you get that from nothing is because it's N or N.
Exactly, right? Effectively, when we're proving something's a theorem, we're showing its logical structure, its syntactical structure is enough to guarantee that it's true. It doesn't matter what sentence N stands for here. This, always true. And that's what this proves. Yes?
Imagine you do have a premise and you want to get to N or not N. Do you just write down this?
Nice, yeah, exactly. So here's the cool thing. Whenever you have a proof of a sentence as a theorem, you can run this proof if you have stuff too.
So if our premise is P or Q?
Yeah, we could copy all of this over and then just, instead of 1 through 5, it's 2 through 6.
Yeah.
And we could get that same sentence if we wanted to.
Yeah.
Right? That's perfectly fine. What we're showing is that this doesn't depend on anything. We don't need any assumptions. But if we wanted this sentence, say for example, we wanted to show, we'll use the nice symbol, that, if we wanted to show this, what would it look like? It would just have this, and then we'd copy all of this and paste it in, suitably numbered, renumbered, and that'd be it. It'd be done. More generally, if you know how to construct a proof, you could always run that inside something else. It's fine. Okay, good. Please.
I don't get why there isn't an assumption and why there would be an assumption.
Good. So importantly, what we're trying to show, again, if we're showing that a sentence is a theorem, we're showing that it doesn't need anything to make it true. The structure of the sentence alone suffices to make the sentence true.
So what does need assumptions to make it true?
Lots of sentences, right? Easy one. Note that we're not going to get B on its own. In order to get to B, you would need A conditional B and A. Most sentences aren't theorems because most sentences need to be derived from something else.
So is it possible for it to be a theorem if it's a conditional?
Yep.
You need something else or
Can we think of one? Here's a good one. Can we think of a sentence? Yeah.
a conditional A?
Exactly, yeah. Note, if A is true, it's true. If A is false, it's false. How would we show it? How would we do it in the natural deduction? Right? So let's do it. That's a good one. So let's show. First question, what's this say? Yeah, we're gonna give a proof, but importantly, a proof with no assumptions, right? We're gonna show that this sentence is a theorem. So we're going to start with nothing, and we're going to end up with this sentence. So, we're going to prove that this is a theorem. How would we do it? Subproof? Nice. What's our subproof going to start with? You're on it.
A.
Yep.
And then yeah.
You got it.
A again,
And what's the rule?
right? And now E, 1.
Well, so it's not going to be E. What's the rule we use here? What's the rule we can use for 2?
Oh, is it conjunction?
So in order to do conjunction, introduction, or elimination, for elimination, we need to already have a conjunctive sentence, which we don't.
Oh, then it's condition.
Close.
Okay.
It's okay. Can we help her out? Yeah.
Reiteration.
Reiteration, right? It's a really stupid rule, but it basically is just that we can repeat it.
Oh, yeah.
Right?
That's why I didn't know.
It's okay. Now, cool. What can we do at step 3? We've finished everything that we need now from the subproof. What can we do at step 3?
We can say if A then A.
Yeah. And what's the rule?
Conditional introduction.
Nice. Nice. We got it. And we cite the subproof, right? So, again, this kind of comes back, right? It's going to turn out that there are sentences with different operators that are going to be theorems. Some of them will be conditionals, some will be disjunctions, some will be biconditionals. What's an easy one that's going to be a biconditional? A if and only if A, right? Right. That's an easy one. But again, note that what's interesting, if you want conceptually the idea, a theorem is a TFL version, a TFL natural deduction version of a necessary truth. And most sentences are going to be contingent. Some of them are necessary. happens when we... Anyway, so the last thing to say, just to wrap up, what we're going to do next is we're going to build off this natural deduction system. In particular, one thing that we have not given you any tools to deal with at all is we haven't given you any tools to deal with the notions of must and could. That is, it has to be and it could be. Possibility and necessity. That's what we're going to tackle for the next 2 weeks. So next week we're going to work on natural deduction for modal logic. That is logic that lets you talk about what must be or what could be. And it builds directly on the stuff we've been doing. Now I'm going to ask, it's going to be hard, but that's fun. So please read the chapter. It's short. It's like 10 pages. We'll talk about it next week, and we'll talk about this stuff again in the tutorials next week. What we're going to do on Thursday, some more of this stuff, just to make sure we've got a good grip on the natural deduction. Most importantly, in between, have a lovely, lovely, lovely time, and we'll see you all Thursday afternoon.
Thank you.